Welcome back to the video lecture series for Introduction to Data Programming using Scala. In the last video, we basically finished our Tron game. I actually want to continue working on this, but we're now going to switch it up. So in the previous videos, we were developing this application using RMI, and what I want to do is I want to make two new versions of, well, a new version of our server and a new version of our client that do this, and we're going to change it so they don't use RMI. So copy, paste. Is it going to allow me to do that? Let's call it socket Tron client, and then copy, paste, socket Tron server. Open the client, open the server. First thing, these methods go away, or the traits at the top. We only needed those for our RMI. We're not going to be using RMI. I can remove all of the imports for RMI. We're going to call this socket, and it doesn't have to extend anything here. Over on the server side, we can do the same thing. I don't need any of the RMI code. Because I've just changed up my classes in significant ways, I'm actually going to clean the project. You can see that it's going through and rebuilding. What the clean does is it causes it to erase all of the compiled files and rebuild new ones. Okay, so what needs to happen in this new version? Well, we're going to make it so that instead of using the RMI, instead of using remote method invocation, it's going to connect using standard sockets. And that's interesting to note. That says that that has no errors in it. We'll see in just a second. There is no more server. This code here is going to change. Actually, let's Control Z. Okay. It's still a I'll put some question marks in there. And let's get rid of the other aspects that we're referring to RMI specifically in here. So because we're writing this as a standard networked application now, I need to have a socket, and on the server side what we're going to do is we're going to open a server socket inside of here. So instead of starting up a registry and connecting to the registry, we are going to create a new server socket. And how about I go with 4444? We'll import that. Okay. And then I need to basically wait for some connections. Now we have a method in here that we wrote previously that is intended to do connections for us. And it's synchronized on our clients. Our clients is a mutable buffer of player. The nature of our player is going to change a little bit here. We no longer have the Tron client. Instead, what we're going to have is a socket for each of our players. And we also need probably to keep track of streams. And I'm going to go ahead and make an object. I'm going to wrap these things so that they're in object input streams and object output streams. That way I can serialize whole objects across. It'll make our lives a bit easier. carriage return there. Control-Shift-O to import those. Okay, and so this becomes a mutable buffer of player. Our server needs to sit here and accept on the various players. So while clients is clients.size is less than 2, what do? Well, I get a new socket, and once I have that socket, I'm going to open up the input stream and the output stream for it. So we will actually, let's go ahead and how about I just call connect on sock. And so then this changes from the client to a socket. Because of the way we're doing this now, this no longer needs to be synchronized. It doesn't matter. With the RMI, the function calls could come in and they would happen across multiple threads and be in parallel. Here, this is actually a call being made from our main thread. And so after it's done with connect, it's going to come back here and wait for the next one, and we will have to come back to here and finish that off. So what do we get? Well, I don't need to do that check anymore. Turns out we're going to stop accepting connections. I just got a socket, so I need to pull the streams off of that socket and wrap them up appropriately. So new object input stream buffered input stream of sock dot get input stream. Control-Shift-O to import that. And we'll make an output stream, and the output stream. Import there. Okay, and now instead of this first part, we have sock, OIS, OOS. Okay, so now the first player connects, it calls to the connect method. So I'm trying to reuse some of the code that we had written before. It passes the socket in. We open an input stream and an output stream to the socket, and we're going to remember those, store them inside of the player, and then we set up our players at the 2 locations that they had been before, same way we were doing before. Now this is going to change. We no longer start game here, and we need to respond to our users, whereas with the RMI, this was being returned to them. Now nothing's going to be implicitly returned, so we have to be much more explicit about this. This method is being called, it's not giving anything back to them. Instead, I'm going to call a write int on the OOS, and then I want to make sure that I flush that. Okay, so after we have opened up the streams for the new player, we add them to our list, we write to that player their player number, and we flush it to make sure it goes, and then we wait for the next player. And then we'll do the same thing for the second player. Once we have done that with the second player, we're done with accepting. So we jump out to this to-do, which is going to do what that code down here did, which is to call start game. Okay, so I need to put a call to start game in here. And what did our start game do? Well, it was calling the players and telling them that, sending them a message through RMI. Let's come back over to the client here and start talking about what needs to happen on the other side. So what is our server now? Instead of calling it server, how about we call it sock, because it's going to be a socket. For now I'm going to hard code in, this is localhost. Obviously for a real application we would like to have it so it goes to whatever machine the person wants to connect to. And then I need to open those same input streams and output streams. Actually, since I already have that code over here, copy, paste, do some importing. Okay. Now I have both of these, and what I will immediately do is read int on the input stream. Because what did the server immediately do? As soon as the server had this all open and had the new player added to the list, they sent that new player an int. So I want to read that int off, and that will be the player number. Okay. Now, so we come back over to here, and we've started the game. And when we start game, what this is set up to do initially is to give each one of the players a countdown. Is this still called clients? Yes. So I need to run through each one of the clients and then send them another message. Okay. So I want to now, here's an interesting question, and in the sense that we know how this is going to work to a certain extent, I will go with writing an int here. Actually, let's not write an int. I need to write an object, and I want this to be a countdown of I. And you might ask, well, what the heck is a countdown? Well, I need to create some little types in here. So I'm going to create, and I'm going to use case classes for these. Case classes, as my memory serves, are serializable. If not, we'll have to put that in there. No. Once again, I've been programming in C++ recently. Okay, so the countdown is a case class that takes an int, and so down here we can write that across. And you'll see why I want to do this when we go over to the client side. But let's stay here for just a bit and look at what we need to do in the rest of this code. This all stays the same. Clients for each we call move, which is a call up to here, which takes a single player. It's all happening on this side. This moves them, it checks whether they die, blah, 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 that's all fine. Now we have this code down here, which needs to tell each one of the clients that a step was taken and send to them the entire mutable buffers. Okay, so I want to do the same thing that I did above, and I want to write an object. And the object that I want to write now could actually be called case class step taken. What is inside of a step taken? Well, a step taken has 2 mutable buffers in it. So P1 is a mutable, actually I don't care that much. Let's go with sequence. Sequence of int, int, P2 is also a sequence of int, int. Okay. So now what I can write down here is write object, and the object that I want to write is a step taken of P1, P2. We sleep and we repeat. Sleep, repeat, sleep, repeat, sleep, repeat. Okay. We'll have to, there's one minor little problem that we have in here, but we're getting close. OS dot write object game ends with the winner. Let's make a case class up here for case class game ends winner whiner isn't it? Oh my goodness, and now this entire code compiles. Wouldn't it be nice if it actually ran? Well, technically it'll run, most likely. We'll see when we actually start running it. What about this side? Okay, so we have these sockets. We read the first number, which was our player number. We have this panel. It's going to draw itself. Okay, our first error right here is turn left and turn right. And we also have these different methods down here that are never being called. Because what's happening instead is that we are sending things across our socket. So what should happen here? Well, it turns out this is actually fairly easy. Just like we replaced our remote method invocations in the server with calls to write object, I'm going to do the exact same thing here. I am going to make this do the object output stream, write object, and then turn left of player number, write object, turn right of player number. So I will put inside of here case class turn left int num is an int, turn right does the same thing, and once again now this code compiles, but at least it not showing many errors. Okay, there we go. But the problem is right now both sides are sending lots of messages to the other side, but neither side is reading them. So we're going to come back in our last video in this series, and we will make it so that each one of the client and the server is reading messages and calling the methods that we had been calling with RMI based upon the messages that are received through the sockets.